Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Yeah, thanks for having me. I've been here all week, and unfortunately, there's so many people here at MSR, I haven't been able to meet all of you yet, too. So hopefully, be able to catch up with some of you, too, sometime. So Jalen thought it would be good if I just sort of give an overview of the research I've been doing for the past few years at Carnegie Mellon, sort of give you a sense as to what sort of the latest stuff we're up to. And for those of you who aren't too familiar with my work, basically it can fit into these three areas. I do a lot of work in privacy and security. There's also mobile and ubiquitous computing, as well as human-computer interaction. And I also thought it'd be nice to sort of give you sort of like very quick overview, sort of the past work, and you can sort of see where the trajectory has been going to. You'll sort of see there is sort of a method to the madness in terms of the rationale where things have been going. So basically, a lot of my past work has been in phishing. So when I first got to CMU, we looked a lot at why people fall for these kinds of scams. And so if you actually look at a lot of the security problems that we have today, a lot of it is actually the person behind the keyboard. So it doesn't matter how many firewalls you have, how much encryption you use, and so on, if the person behind the keyboard falls for one of these attacks. And in fact, if you look at the data, it's actually pretty surprising, because recently we've had the secure ID problems where they broke into the secure ID by RSA, Lawrence Berkeley Labs, Oak Ridge National Labs, Canadian governments, Australian governments. There's also Gmail attacks on State Department employees, and so on. So it's actually a sort of timely research. We've also looked at a lot of ways of how to protect people too. So basically we use online games as well as simulated phishing attacks to train people. So basically if you fall for one of our fake attacks, then you get the just-in-time training. And we also demonstrated that was very, very effective. So in terms of the results, we have about 500,000 people using our software through our startup. Some of the other work that we did also helped influence Microsoft Internet Explorer 8, the design of the warnings there. We've also had a lot of people adopting our work by the Anti-Phishing Working Group, which is an international consortium to fight against e-crime, and also some of these articles in Scientific American and Communications with ACM. Some of the other work that we've been doing, too, is looking at location-based services, too. So one of the things that I've always been really interested in is, given that we have all these mobile devices, what can we do with this kind of location information, as well as how people manage their privacy? So one of the main systems we've been working on for several years now is this thing called Locationo, where we've been trying to understand how do people specify rules for disclosing their location information, and generally how do people's concerns change over time with respect to privacy. And sort of one of the surprising things we found in this study is that people generally become less concerned over time the longer they use the system. So generally speaking, they had about 4 to 5 rules, and they tended to relax the rules to allow more people to see information about them over time. We've also looked at things for place naming, too. So the answer to the question, where are you, is actually a very deceptive kind of question here. Because I could legitimately say I'm in Seattle, I'm at Microsoft, I'm at Microsoft Research, I'm in Building 99, or room 2535. And all of them would actually be legitimate answers. In fact, you'd also say I'm on planet Earth, which is true, but also sort of useless, too. So we also looked at different models for how people name these places and how do we automatically infer those, too. Also, alternative visualizations of locations. So, for example, rather than just showing maps of where people are, you might also show other kinds of visualizations, too. One of the main reasons for this is it turns out people don't like disclosing the location of their home on a map. And it's also not very useful because a lot of people don't know where home is for that individual. But just having a label home turns out to be quite useful. If you haven't used the system Foursquare, I'll also talk about a little bit of that later on. But it's actually sort of a surprising system. They claim to have about 20 million users or so. And we're looking at why do people actually use this system. It's actually a really interesting one, too, because if you've studied Ubicomp research and location-based services for a while, there's been so many failures in terms of people not using the system we've been building. And I would say Foursquare is really the first time we've actually had large adoption of one of these location-based services that isn't just navigation. And we can finally start studying, what is the interesting parts here? Why do people use it? What are the interesting kinds of ways that they've co-opted these systems? And we've also had one startup, I'm not affiliated with this one, but looking at commercializing some of these technologies. So that was sort of like Act 1 of the research career. And so, what do you do for a follow-up on this one? So what I've been looking at more recently is, these smartphones, too. So smartphones was always a main theme of the research. But, we've been looking a lot more at this because of the amount of good that can be done with this, as well as sort of the evil that can be done with that, too. And remember, you can only use your powers for good, right? So, if you look at these smartphones, I'm guessing probably almost everybody here has one of these smartphones. They have your location data, they have your call log data, SMS, pictures, your contacts list, they know what apps you run, and so on. All this rich amount of data. Okay, so what can we do with this in terms of good? So two of the things that we've been looking at, two of the research thrusts, one is this augmented social graph. So how can we use this data to try to build better models of who we know and how well we know them and so on? And I'll give you some reasons as to why this might be useful. Another big thrust we've been looking at is this thing called urban analytics. So once you have location data for thousands of people in a location, what kinds of things can you do with that? And so we've been using this to try to understand the character of a city. And the last thing I'll talk about in this talk is, well, the opposite side of this. How can we actually protect this information from other kinds of people or malicious kinds of attackers? So I'll talk about some of the work we've been doing on crowd scanning, where we've been trying to use crowdsourcing to understand the behavior of these apps. And so I'll start out with this augmented social graph. And the main goal of this one is to build a computational model of a person's social graph. So this includes a person's tie strength, relationship, and role. So if you look at, for example, your contact list in your smartphone, or if you look at a lot of these social networking systems, a lot of them are like this, where you just have a blob of friends. And it doesn't really have much understanding of, well, is this your family member? Is this a close friend? Is this someone you've never actually met in person? So there's all this rich data that isn't being captured there. And what we're trying to transform that into is something more like this, where it would know, well, these are your close friends. These are your strong ties. Here's your weak ties out over in the periphery. And also might know these are your New York friends. These are your surfing friends. This is your family, and so on. Yeah?
This social graph is intended for service providers to leverage for users.
Right. So that's a separate question. First part we're looking at is, can we even build this? The second part is, where should it actually live? So does it belong to, say, a service provider, or does it belong on your phone? For privacy reasons, we would probably argue more on the phone. And plus, a lot of the other data sources that we're drawing on, they're not really integrated. So that would be the most likely scenario, is that it would be living on your phone.
Do you also use the web services not like for me and from or
Yes. Well, that's sort of the next slide. Why would you care about this? Yeah. Brian, you have a question? Mm-hmm. Right. Oh, yeah. That's actually a really good idea. In fact, these images are actually adapted from Paul Adams' slides. Paul Adams was the guy who helped do a lot of the ethnographic work and interviews that led to Google Circles. But then he also left right afterwards, and now he's at Facebook. Yes. Right. So why would you care about this? So in some cases, one might be secure invitations. This picture is a person of someone named Robin Sage, and it's not really her name, but basically a black hat hacker was trying to find out how many people can I trick into friending this individual. And so basically they tried two strategies. A, get attractive young woman, and B, friend people who just basically accept all friend requests. And then by the time I want to get to you, then it's like, hey, there's 12 people who also know her, and plus she's attractive. So that's sort of the strategy that they were using. So you can imagine if you had one of these things, you might be able to say, well, all 12 of these people have never met her face-to-face. And something like that could actually be useful in trying to prevent these kinds of attacks. Communication triage might be another one, so trying to prioritize who you're trying to communicate with, understand who the different individuals are. Better information finding. So the weak ties, it turns out, is much better for finding new information. So one thing I was telling Jaehyun and Ratul is that, well, one of the things we know in social science is that you tend to know the same information that all the other people around you know. And so that's why it's actually useful to bring me in, because I know a completely different set of information and have a different sort of heuristic and thought process, which can bring in sort of new information for the group. Configuration of privacy policies is another one, too. We have a study done at UBCOM 2011 showing that tie strength is actually strongly correlated with what you're willing to share with other individuals. Now, this isn't actually too surprising. I mean, you're probably more willing to share things with your close family and friends. We're actually just the first ones to document what are the kinds of things that people are willing to share with those individuals. And the other one that we're also looking at, this one is one of the main kinds of applications we're looking at. This other one is the other one we're spending a lot of time on, early detection of depression. So if you know, for example, you have less communication with your strong ties, and combined with other smartphone data, like your mobility seems to be going down, you're going to lots of fast food restaurants, which turns out to be strongly correlated with depression. So if you guys are going to lots of fast food restaurants, yeah, be careful. And the main reason is basically loneliness. It basically suggests that you're not eating with friends if you're going to lots of fast food restaurants. And insomnia is also something you can probably detect on these ones. Yes? Yes. It would be grad students and parents with new babies is another possibility. Right? Yes. So we're aware of that kind of possibility, too. Okay, so this is our first foray into this, which is using location to infer the friendships. So this is basically an opportunistic research because using Locacino, we had actually collected a lot of data about where people were going in Pittsburgh. And then one of the grad students had this insight, which is, well, can we actually use this data to infer interesting properties about these individuals or the places that they're going? And one of the main things to take out of this is actually this notion of something called place entropy. So place entropy, this is an idea that we borrowed from ecologists. So they were trying to understand the species diversity in an area. So basically take any kind of area, square meter, square kilometer, whatever, count the number of unique species there, and then use the same entropy formula that you would see from Claude Shannon. So they borrowed it from Claude Shannon, and we borrowed it from ecologists. And then this gives you sort of a sense as to the number of unique species seen in an area. We did the exact same thing, except looking at the numbers of unique people inside of an area. And this sort of gives you a sense of the social quality of a place, because if you are in a place with high entropy, that means there's lots of people seen there, which probably means it's a more public area. But if you're in a low entropy place, then it's a place where very few people go. And so this might give you a sense as to the kinds of friendships that might, or a better signal of friendship. Because if you're co-located with someone in a high entropy place, that's not a very strong signal. Because right now in MSR, you're co-located with probably hundreds of people that you don't really even know. Whereas if they're co-located in your home, which is a low entropy place, that's a much stronger signal that you're probably going to be friends. Yes, Lito? In this case, it's roughly about 30 meters by 30 meters. Basically, if you take a GPS grid, latitude and longitude, and it's roughly like 0.002, and then just basically turn that into a grid. And it turns out that that was a really simple model that just happened to work really well. And you don't have to worry about what's a place, what's not a place, and so on. So we lose a lot of semantics, but it's far easier to process, and you don't have to worry about all of the messy semantics issues. Is that your question, too?
Right.
Okay.
My question is, if you look at the semantic construction, does it stop being more tell you because fairly accurate data
Right.
Did you find anything surprising by using this entropy as a measure?
Not yet, but I'll show you some other surprising things that we found through it, too. And you're right, I think you're right, too, that if we can get more semantics about these places, we probably could do much more interesting things. So we haven't gotten around to that yet. But, there's a lot of these kinds of, yellow pages we could use, the web pages with street addresses we could use, and so on to get a better sense of what's going on. Okay, so here's the entropy map for Pittsburgh. It's a little bit messy on this projector. Basically, here's Carnegie Mellon. It has a lot of red areas where it means high entropy. Over there, here is a dining and shopping area right next to Carnegie Mellon, which is called Craig Street, if you're familiar with it. And here is also a very high entropy, for obvious reasons, because that's where we go out to lunch. Here's the residential areas, which are very low entropy areas. Okay, so this sort of matches what you might expect, too. This doesn't work well for urban areas, but it seems to work well for sort of semi-urban areas like Pittsburgh. And so what we did is we developed 67 different machine learning features. So we had things like location diversity and entropy. So again, are you co-located in a place with high entropy or low entropy? Intensity and duration. So duration is how long you've been using our system. Intensity is how many different co-locations you have with us or with another person. Mobility is, do you have sort of a regular schedule or do you have sort of an erratic schedule? Specificity is basically TF-IDF. Is this a place where I spend a lot of time in and lots of other people don't? So an example of that would be my home and my office. And there's also graph structure. So how many mutual neighbors do you have and how much overlap there is. And so it turns out we used an SVM classifier, and we got about 92% accuracy in predicting friends or not. Though that's actually sort of misleading because prior probability of people not being friends is actually pretty high. So instead, we'll show the precision and recall graphs. And sort of the main thing to get out of this is that using features like location entropy really does help improve things rather than just sort of the shallow features of raw co-locations. So the raw co-locations is over here. Here's the precision and recall graph. You can see it's actually not that great when it starts out over on the far left side. And then as you add in the different kinds of features, the precision recall actually does improve pretty well. So you can see right here, here's the full model. And it does much better in trying to predict who's likely to be friends. Yes?
Does the full model include the structural properties in the one without, are you including entropy and structural properties?
Yeah, it includes all the different features I mentioned here.
Well, I was curious how much the structural properties help versus the location entropy. Do you think structural properties that essentially would be helpful?
Yeah. I'm pretty sure that would be too. I don't know offhand, but yeah. Okay, that's a good question. Another sort of interesting finding we had is you can actually correlate the number of friends based on mobility patterns too. So basically, people who go out to high entropy places, especially on weekends, or people who go out often, especially on evenings and weekends, tend to have a lot more friends than people who don't. And then, we thought about this for a second. It's like, well, actually that does make sense because, here's this grad student who goes to all these different parties, and looking at my own location patterns, it's like, wow, work, home, airport, work, home, work, home. So you can probably guess, my number of friends on Facebook isn't really that high. But this is actually sort of interesting. It sort of suggests to us that just based on raw location patterns, we might be able to infer other kinds of characteristics about individuals as well, too. So, one obvious one that people talk about is, well, maybe you can infer people's personality types based off of this kind of stuff, too. So we had 10-variable model. The R-squared value, it's reasonably good, so 0.21. But here's sort of another interesting finding we've had with entropy, which is that entropy also seems to be correlated pretty well with location privacy concerns. So this graph basically shows you on this x-axis, here is the entropy of location. So 0 means basically you're the only person seen there, and 4s and 5s means lots of people are seen there. And we had self-reported comfort level in different locations. So 1 means you're not very comfortable sharing your location with this group, and 4 means you're very comfortable sharing your location with that group. And so friends and family are the ones at the top bar, so people are generally okay with sharing the location. But here's the interesting one, which is this is everybody. And you'll see it actually goes up as the entropy goes up as well, too. So that also suggests to us, well, maybe this could be a useful way of generating default policies for an entire city without really knowing any of the specific individuals. So you can imagine, well, if you're trying to deploy a new kind of location-based service, this might tell us, well, these are the places you shouldn't be recording people or sharing the location, and here's locations where they might be okay with sharing the locations as well. So this is sort of an early result. This is also in Ubicom 2010 if you want to see the full paper. But we think this might also be sort of a promising direction for location privacy in general. Our ongoing work in this is trying to get richer data, too. So the past work was just location data. What about all the other smartphone data I mentioned? So the current work, we actually been collecting Facebook data, smartphone data, and ground truth data from 40 participants. The ground truth data basically is, what is your self-reported tie strength with this individual on a scale of 1 to 5? Which groups do they belong in? So you can create your own groups. And also we did this for 70 different contexts. And we're using this to model tie strength in groups. And so just to give you sort of intuitive reason as to why we think this will work well. So this is actually my call log data. This is my wife's contacting me. If you just sort it based on raw number of calls, she's number 1. And of course, the first time I showed her this, she said, I don't call you that often. Right? But yeah, actually there's lots of these small calls, and there's a few of these long calls as well, too. And also calls every day of the week, as well as at all times. Here's my brother, sort of the same pattern. Here's my mother. You can see when she actually went overseas, because there's sort of a drop off in these calls here. But if you compare this to sort of like other individuals, so here's like one friend, here's an unknown, and here's one of my best friends here. And so you can sort of see a different kind of pattern, like long calls, but not very often. So that's sort of the current work that we're doing, and we're trying to analyze this and build much more of these models and see how well they work, and also how well they generalize, too. Okay, so that's sort of the first part of the talk, the augmented social graph. The next thing I wanted to talk about is the work that we've been doing in urban analytics. And so sort of the rationale behind this one is that today's methods for understanding what's going on in a city is really, really slow and expensive. So for example, Minnesota does this thing called a travel behavioral inventory to try to understand traffic flows, and they do this every 10 or 20 years. So basically, they give GPS to maybe about 100 people, and they recruit about 1,000 people to do diary studies of where did you go, where are you going, why are you doing this, and where did you start, where did you end, and so on. It turns out that this travel behavioral inventory dictates all the resources they allocate for the next 10 years. Right? And so you can imagine this is pretty coarse-grained. It's a small amount of people, and it's also fairly coarse-grained. The U.S. Census costs about $13 billion to do, and they're still processing the data. Quality of life survey is also done by sociologists and city governments. So this is where they go door to door in specific neighborhoods, and they ask you, how are you feeling today? Did you manage to buy any fresh food today? And other kinds of things to understand how is your life generally doing. And they do this, it's very expensive to do this because you can only do it in a few small areas. It requires an army of grad students or an army of hired professional interviewers, and also a lot of time to do this too. Brian, did you have a question or comment? I think this U.S. Census has all this amazing information about how to get people to be motivated to raise participation. It turns out one of the main things to raise participation is, that's why you get the postcard saying you're about to receive one of these things, and then you receive it. And the question is, why don't they just send it to you? And they actually have a lot of studies showing that sending the postcard increases the response rate pretty dramatically, which is really strange, but it actually works. So there's a whole sort of science in terms of understanding how to get people to do this. In fact, there's a whole science in terms of getting people to donate money to charities as well, too. And so that's sort of a separate kind of topic, but it's really fascinating work. Okay, so what we've been doing here, sort of the vision for urban analytics is, let's take smartphones and social media and machine learning together to try to generate new and useful insights about what's going on inside of a city. So to try to understand the structure and the character and the dynamics of what's going on. And part of the reason for this, you'll notice the new thing here is the social media compared to the past work. And the main reason for this is because, again, we only had 489 participants, 2.8 million location sightings, which actually, it sounds like it's a lot, but it's really not. It's a really small sample. It's also, pretty biased in terms of who we're getting. We also don't have a lot of coverage around the city. And this is where the social media, I think, can really address the problem. I think this is really the sort of new angle that will really help us be able to do this. Yeah? Yeah. Yes. So that's something we've talked a lot about, too, with some other folks at Carnegie Mellon. And one of the early studies we did was just plotting where people are taking geotagged Flickr photos. And there's like a huge gap in Pittsburgh where it's pretty clear it's the lower socioeconomic boundaries. And so we don't have a good solution for that yet. But sort of our suspicion is that as the cost of these kinds of technologies lower and they become more pervasive, then I think that it might become a problem that solves itself in time. But in the short term, where we currently are, it's definitely going to be a problem. And in fact, you'll see other biases, which I'll point out in how we're doing our method right now. But despite these methods, we're still finding some pretty interesting results, too. Yeah. Right. Right. I mean, this sort of goes back to the old kind of question, quantitative versus qualitative. And, I'm a fan of these mixed methods to understand sort of the full picture rather than just relying on one of these methods. And so you'll see, actually, that we use a combination of these methods. So we do use some of the machine learning, but we also use interviews to evaluate how well the machine learning techniques are working. So here's our first urban analytics tool. It's called Livehoods, and you can also check it out on livehoods.org. We have 4 cities right now. So we have Pittsburgh, San Francisco Bay Area, New York, and Montreal. So we don't have Seattle yet. But if you're familiar with those other cities, you can also take a look. And sort of the working assumption we have here with Livehoods is that the character of a place is defined not just by the places that are there, but also by the kinds of people that are there, too. Okay? So let me give you sort of an example of what I mean by this. So, think about your own home neighborhood for a second. And so the odds are high you're probably not thinking of, sort of the political boundaries or something like this. In fact, when we talked to, given this talk several times to lots of different groups, we've only found really one person who thinks like this, and it was urban planner, essentially, whose job was to think of something like this. But it's more likely you're thinking more like this. So you're thinking of, okay, the kinds of people that are there, the kinds of stores that are there, is it sort of like a safe place, has nightlife, and so on. And so this is a really nice quote by this individual named Kevin Lynch, except it's cut off there. Every citizen has had long associations with some part of his city, and his image is soaked in memories and meanings. And one thing that's really fascinating about Kevin Lynch is he actually did a whole bunch of these studies to try to understand how people understood their own city. So he actually had a lot of people draw maps of Boston and to understand how they navigated and how they understood the city. And sort of one really funny finding he had there was that in Boston, everyone's conceptual map of how it worked didn't match at all what the physical layout of the city was. Because if you've ever been in Boston, apparently it's like all these curvy roads and there's no grid and it's really confusing. And one of the main findings he had was that, well, everyone navigates based on landmarks. So they'll say, okay, go this way, go past that store, and then take a left. Whereas I've noticed in Seattle, it's like everything's a grid. It's like we're up to 129th Street or 34th Street. I suspect everyone here probably navigates just based off the grid because it's much easier to do. Stanley Milgram, this is the famous Stanley Milgram. He's the one who did 6 degrees of separation, the shock experiments, and well, it turns out he also did other cool stuff too that didn't involve, like violating all the human subjects rules. But very, very influential work. Well, they didn't exist, but he helped influence their existence. But one of the cool things he did was ask people to draw maps of their city too. So he also had the same thing, and so he did it for Paris as well as Manhattan. So you can see here sort of Manhattan Island, So sort of people draw this wider here, this Central Park, here's the financial district, Statue of Liberty, which probably is more like over here realistically. And so, you know, this is just sort of like one person's conception of what they thought, you know, Manhattan looked like. And so here we sort of see this difference. There's sort of the formal fixed boundaries defined by the government, and there's sort of like people's understanding of what's going on, the character of what's there and sort of what goes on there, as well as the organic boundaries. And so sort of what we're looking at here was, well, can we automate some of the ways of trying to identify the organic boundaries? Sort of the difference between the formal boundaries and people's perceptions of them. Can we also try to understand sort of the local knowledge, and can we also try to build sort of collective maps of these things? Yeah, Stuart? Right, right. Right. That's a really good point.
If you're in New York, it's very unlikely you're using by car. You're also doing it for dark and you go underground and there's humans.
Right.
I would refer to that as the gopher's
Okay.
perspective on city structure, which is, again, as we see for a lot of those Bostonians, right, they get in.
The big dig.
They get in slow and they get in it, right, they need landmarks in part because, right, they're essentially teleported.
Okay.
They get into the city at one point, and they go down, and then magic happens.
Right.
Another point without seeing the progress that they
Right. That's actually a really interesting point. I don't think that these studies controlled for that. They're just basically asking people who lived in the areas. The only kind of study where I've seen where they do have other kinds of variables, this was actually published at the most recent CHI, is looking at Foursquare usage and how it affects people's cognitive maps. Sort of the surprising finding they had was that people who use Foursquare tend to know more neighborhoods than people who don't. Right? And it sort of suggests that that actually is one of the effects of Foursquare, which encourages people to explore more areas of a city. So that might be sort of a positive thing. But I haven't seen other studies describing what you were saying. And that actually might be a really interesting one to do, too. Okay, so going back to this. So what we're trying to do, again, is look at the differences between the political boundaries and people's perceived boundaries and look at different techniques for trying to understand this. And sort of the way that we're doing this was using Foursquare. Basically what we did is we crawled 18 million check-ins from Foursquare. If you haven't used Foursquare before, it's sort of a game where you can say where you are and share your location with other individuals. They claim to have about 20 million users, so probably divide by 2 or 3 because most internet services are like that. You probably have a really long tail of users. But what's really interesting is this is what you would see if you used Foursquare right now. You would see, okay, here's the building 99. You can check into it. Yesterday when I got the screenshot, there were 2 people who were already checked in. I was one of the 2, it turns out. And all the different kinds of things that are nearby. Now, by default, Foursquare is private, so you don't actually see any of these check-ins. What we did is we found people who linked their accounts from Foursquare to Twitter, and then we looked for the public tweets where they said, Jason has checked into X. And then we just crawled for those. Afterwards, what we did is we used spectral clustering based on geographic and social proximity. So I'll give you an example, sort of intuitive version of what that looks like. So imagine this is New York City, and you have these 2 people who are roughly going over only in these areas over here, and you have these 2 individuals that are only going over to places in this area. And if you can imagine a graph version of this, then this graph right here, the thickness would indicate that lots of people who go here also go to this location, but few people who go here also go here. Right? So it suggests that there's not a very strong tie between those 2 things. And then basically what spectral clustering does is it tries to find the weak areas where you can sort of split the graph and then start doing the clustering based off of that. So sort of from an intuitive perspective, this is what you might end up with if you had sort of that kind of graph structure. And so if you want to check out the Livehoods site, it's livehoods.org. Let me take you through sort of what we did with the evaluation of this. So what we did is we interviewed 27 locals who lived in Pittsburgh. They were residents, urban planners, as well as businesses. And we asked them to draw their mental maps of the areas that before they actually saw our maps. So we wanted to get a sense as to what did they think about their city first. And then we wanted to compare their mental map to our mental map. And so we showed them our maps and then also gave them some feedback. Now I'm going to tell you sort of a case study with respect to the south side of Pittsburgh. So this sort of gives you a sense as to what south side of Pittsburgh looks like, sort of more of the hippie area. There's a lot of bars and a lot of tattoo parlors and so on. So yeah, definitely an area I spent a lot of time in, as you can tell. So here's sort of like one way you might conceptualize the south side of Pittsburgh if you only knew the geography and if you knew where all the stores were, but you didn't know anything about the character of the place. Like, again, who goes there? So this is Carson Street, the highlighted area. So you have a lot of restaurants, tattoo parlors, clothing and furniture shops. And this is really the area that everybody goes to for nightlife. You have this other area called Southside Works. This is a mixed-use outside shopping mall. And they also have some condos, upscale restaurants, and so on. You have this older strip mall area, which has a supermarket and a grocery store there. There's also a liquor store, auto parts mall, and so on. And then you have a whole bunch of residential areas where people happen to live. So again, this is sort of, if you just only knew what the stores were, you might construct a map like this. Now, let me show you sort of what the map looks like based off of the Livehoods that we had. And then I'll also talk about the interview results where people were trying to describe, well, did this make sense or not? And in fact, one thing that's really funny is that, when I mentioned that to people in Pittsburgh, that we found several areas inside of the south side, even before they say the map, they usually guess, this one pretty fast. This is a really easy one. But the surprising thing is that everybody says, oh, I bet there's a split around 18th Street, which is right where this is. And I'll explain in a second why that's the case. But it's really funny because everybody predicts that one. So the first one is, okay, everyone, again, finds this split. Not very surprising, but everyone says that the South Side Works, the mixed-use area, is very different from everywhere else. Okay. The next part is this one right here. So I mentioned this before, that there's a split around 18th Street. One thing that's interesting is that there's a change in geography. So it goes from really short streets where you have no parking to longer streets where you actually do have parking. So that's sort of one difference here. Sort of another difference, and again, the main reason why there's a split around 18th Street is that this is where the bars end as well, too. So basically what happens is there's a bridge, and Duquesne University students, they cross this bridge, they go bar hopping, they get to here, they see the UPS store, and they turn around because there's no more bars to go. And again, people are saying there's a very different feel here. If you go to Google Maps or any other place where you can see these kinds of things, you can see that there's just very different kinds of stores. There's a shift there where it goes to more like these formal restaurants, these sort of more upscale kinds of things, rather than sort of these dive bars. In terms of safety, people also mentioned this too. So whenever I was living down on 15th Street, so that's over here on the left side, when I was going down 15th Street, I had to worry about drunk people following me home. But on the 23rd Street, which is in Livehoods 8, I need to worry about people trying to mug you. So it's different. It's not something I had anticipated, but there's a distinct difference between the two areas of the south side. And the last one, this is my personal favorite one. There's this interesting mix of people over there in Livehoods 6. Again, that's the shopping area, where I don't see walking around the neighborhood. I think they're coming to Giant Eagle, that's our local grocery store, from lower income neighborhoods. I always assumed they came from up the hill. And in fact, let me show you this. One of the features we do have in Livehoods is to show you what are the most other related Livehoods. So here's the Giant Eagle. There's that small blue cluster I mentioned earlier. And this is the hill over here, basically. And here's the people who live down the hill, up the hill that this person was describing. So this does sort of suggest that these are the people who are coming to this Livehoods. And again, sort of a different kind of nature of people that are going there. So not necessarily the people who live in this area. There's definitely some people here. But it turns out that there's no other grocery stores around here either. And this is something that the system actually could be used to find. Now, I'm pretty sure not many of you are from Pittsburgh, so I want to show you some other kinds of views of this too. Here's New York City and the Brooklyn-Queens Expressway. Well, I guess not really New York City, but right next to New York City. And one interesting thing here, so here's the Brooklyn-Queens Expressway going up here. And one interesting thing is you'll notice how the Livehoods are also split primarily by the highway as well too. And if you've ever read anything about Jane Jacobs, she was a strong critic of a lot of these kinds of urban areas and urban planning. It talks about how highways are basically trying to split the neighborhoods and making it sort of lower quality of life. But you'll see that this actually does seem to be shown here, that the Livehoods do seem to cluster around this kind of highway. And when we showed this to people at Foursquare as well as American Express, they actually mentioned that one really useful use case of this, which is recommender systems. If you're going to do a recommender system, using raw geography might not be the right way of doing it, because it might actually send you across to a different area which isn't really the same look and feel as the neighborhood you're currently in. So this might also be sort of another way of thinking about sort of perceptual distance rather than just raw geographic distance. Well, it could be, but this is one that already exists for us. This is one that already is there, I would say. And I suspect that if you interviewed the people there, they'd probably say the same thing. That it's, again, probably a very different feel. Mm-hmm. Right. Well, I don't have a good answer for that one. But let me think about that some more. I'd have to think about that some more. I don't have an immediately good response or witty response. If you have ever spent time at Berkeley, what I've done here is I highlighted sort of the 3 livelihoods that was found, and the rectangle also represents the campus, the rough parameters of the campus. So Jay, this one's for you. And one thing that's funny is I had dinner with a whole bunch of the Berkeley folks last Tuesday, and I was describing sort of the results of this. And basically, the southern part of this is primarily all the humanities areas. The top part is basically all the science and engineering. And here's where most of the weirdos hang out, too. Right? So this is sort of my mental model. And I was actually surprised. I was really pleasantly surprised to see that there was a split, because personally, I know that I very rarely spent time down over here. I'd probably go down here maybe once a month or so. So most of my time was spent more in the North Berkeley area. And I suspect that's probably true for most of the science and engineering students, too. So that's sort of the work that we've done so far. I also want to show you, again, that I think this is the beginning of something potentially really big in terms of analyzing what's going on in cities. I'm going to show you 2 quick visualizations that students in my social web class created this past semester. This is sort of a visualization looking at repeat visits and the total number of people that went to these locations in Foursquare. And so in this one, you can see San Francisco Airport is very popular for repeat visits. But this one I thought was sort of a surprise. Disneyland Park actually has a lot of people who go there in terms of number of check-ins as well as the number of repeat visits. And this wasn't really clear to me until I actually asked one of my friends who lives down in Anaheim, why is this? And he's like, oh yeah, we have an annual pass to Disneyland and we go there every 2 months. It's like, okay. Because Disneyland is more of a place you drive to, where Disney World is a place where you fly to instead. So it probably has fewer repeat visits. White House, that was sort of surprising. Probably that means workers, people who work there are probably checking in. And then Whole Foods as well, too, has a high number of people who are visiting and repeating the visits.
The data is over 1 year?
This is probably all the data that we have, so this would probably be over probably 3 or 4 years at this point. It would count as 2 check-ins, if you checked in twice. Yeah. Oh, there are other airports. The other airports are somewhere scattered around here. It just turns out San Francisco is the most popular one. I think this one's also, I think it might be Charlotte Airport. Brian, did you have a comment? Total number of people who have checked in. Right? So it's also mapped to the size of the circle, too. So it has a double mapping here. Yeah. Right. That's part of this other study that we did on Foursquare, which is the projection of self. We found out that people liked checking into cool places and didn't like checking into fast food restaurants, for example, because it's not perceived as cool. But I mean, that's only generally true, because we've also, if you actually look up embarrassing things in Foursquare, you'll see that there's actually people who check in there too. So look up any random strip club, you'll see that there's someone who checks in there all the time, and it's like apparently they're okay with that, people knowing that. It's a really embarrassing search to do in front of people too. So I won't do it here. This is another one that the students have also done, and I thought this is a really interesting one. If you use topic modeling, the latent Dirichlet allocation on this, where you treat the places as documents and you treat the people as words, you can actually find interesting patterns as well too. So for example, number 2 turns out, there's no label in LDA, but if you just eyeball it, it seems to be tourist places. And so it turns out this might be sort of an interesting way of trying to cluster these and try to find recommendations for you, as well as understanding people's patterns. So you can imagine if you're a person who goes to lots of these tourist places, we might be able to categorize you as a tourist. There's another one. This is like a music cluster. This was the gay bars cluster, which incidentally didn't all hold gay bars. There was actually lots of other kinds of things there that I don't know much about these areas, but if we looked at these places or interviewed people, it might suggest that maybe these have some more of these affiliations that is not obvious just based off of the location or just the name of the location. So I think there's a lot of potential here for just understanding, again, more about these cities and to do these kinds of analysis. The kinds of other things we're looking at now is like how do neighborhoods evolve over time. So we're about to get a new Whole Foods and want to try to see what the effects are. We also have historical data after and before and after we had a new Target in Pittsburgh. Looking at different rhythms of day versus night. So for example, downtown, most downtowns are very active during the day, but they're incredibly boring at night. They're basically ghost towns at night. And so trying to map those kinds of patterns. Temporal sequences is something else we want to look at. So what do people do before and after church on Sunday mornings? So you can imagine trying to find those sequences and see if there's interesting patterns there that might help people understand these things. Well, no, that might be one. And, I suspect in Los Angeles you'd see something like, people are at home, go to church, and then Korean restaurant. And that would probably suggest because there's a lot of Koreans who go to church in Los Angeles. Also demographics as well too. So what do Chinese people do in Pittsburgh? So to give you an example of why this might be useful, this is actually a big surprise for me because I lived in Pittsburgh for several years and I didn't know this. But on Saturday mornings, a lot of Chinese people go to a Taylor Alderdice High School, and it turns out that's just Chinese school. But I didn't know about this, and I lived in Pittsburgh for several years. And so, in Pittsburgh itself, it's actually pretty easy to do this kind of query because there's only 2 Chinese grocery stores. You do sort of repeat visits on Chinese restaurants, and then you can sort of filter all that out and try to find other kinds of patterns. And this might be useful, again, for recommender systems, but other kinds of things like sociologists, and maybe the urban planners would be probably more useful for these than this one over here. Okay, so that's sort of the high-level overview of the urban analytics. Does anyone have any other last questions before we go on? Yeah, Brian. Oh, right. Yeah, so one of the big biases was the fact that it's Twitter and the fact that you're using Foursquare. So that's already 2 biases right there. But what's sort of surprising to us is that once we released this was back in April 2012, we probably had about 20 different urban planners from different cities wanting to work with us to try to figure out how do we use this data for our own city. Because the problem that they have is they essentially have 0 data right now. And they're trying to make their best guess, and they can't even present any kind of data to make arguments because it's just too expensive to collect it. So I would say that, yeah, there's going to be biases, but I think something like this could still help in terms of trying to understand what's going on. Helping them understand, origin, destination, which is one of the big things they have to worry about, but just sort of understanding, how dispersed is a city? Are people going to lots of different places? Is there sort of like a central core to the area? So there's all these kinds of questions that the urban planners really need to answer, and I think that tools like this could really help out. Well, we put in an NSF proposal to big data, so we're asking for $3.5 million. But whether that happens or not is a different question. But I mean, this is one of the reasons why I've been talking to all these different companies. And so, American Express and the Foursquare, and there's a whole bunch of other ones that have been trying to contact us about this. Again, I mean, they have a whole bunch of needs for this. And apparently we stumbled onto something that has a really strong need for them. And also, from our perspective, I'm interested in the science as well as betterment of humanity in general, too. So I think that this could also help out with those. So I think it's going to be much more than just sort of single undergrad. In fact, I mean, it's almost like if I wanted to mimic Marvin Minsky, he actually hired, I believe, one undergrad for one summer and says, okay, solve this computer vision problem. So I don't think I would go that far, but I think this is a really long-term kind of thing that's going to take several years because there's so many different tools, ideas for tools we've already come up with. Also, clustering techniques, better algorithms, adding semantics, and so on. I think there's a ton of stuff that can be done. Yes? All right. Right. That's a really good question. So the issue with using call data records is that I believe that they only are captured when you actually make calls, and the other one is that their location can be off by about 1 kilometer or so. So you get some pretty good data, but you don't get sort of the data, the fidelity that we're getting. So that's sort of a trade-off because it's also easier to get it from those telcos, and because they have tons of that data, but it's also sort of the proprietary data that's also harder to get a hold of. Right. Yeah. Right. It's basically a trade-off here. So it's like there they have huge scale of data. Here we get better granularity of data. We also know more about the venue they're at, and so on. So I mean, there's definitely going to be these trade-offs here. Personally, I don't really like the call data records because again, it's just sort of the you might be off by 1 kilometer, and that's just like a really big sort of uncertain area. So I sort of feel like you don't get as much out of it because of that. Well, if we ever found telcos we could work with, we could try something like that. I suspect that AT&T has been publishing a lot of research recently about how people are moving around cities, trying to build synthesized models and so on. But even their synthesized models are still off by about 1 kilometer in their latest paper I saw. So I think it might be possible, but I'm still a little bit uncomfortable just because of the granularity of the data. Okay, so the last thing I want to talk about here is sort of the privacy side of things. Sort of the joke is that I spend half my time trying to build better privacy mechanisms, the other half trying to break them and find other evil ways of applying them. But I wanted to try to give you sort of an example of motivation as to why this is important. So I don't know if many of you use the Pandora system, listening to music on your phones or smart devices. It turns out that they're actually under federal investigation because they found out that it's sharing a location, gender information, unique phone ID, and phone number with advertisers. And so this is one of the big problems that they're facing. And I don't know if the federal investigation has ended yet, but it's definitely been putting a crimp into their IPO. There's also other systems too. This is the Path mobile social network and Facebook. Turns out they're uploading your entire contact list to their servers. Okay, your entire contact list with the phone numbers to their servers. And so, this is sort of a really big surprise because no one really thought that this was actually going on until one hacker actually looked at it. It's like, hey, what's going on? How do they have this data? And if you look at smartphones in general, a lot of them have these unusual permissions. So tiny flashlight plus LED requires internet access and phone number. All right, your flashlight's going to call somebody. You have backgrounds, which require a contact list, a dictionary that requires location, Bible quotes that requires location. Right? So as some of you have heard this joke before, but the Bible quotes, supreme deities need help from smartphones to figure out where you are, apparently. So, if you actually try to investigate why this is the case, you have, a lot of these apps are actually getting your data for advertising reasons. Right? So they just want to try to figure out where you are so they can try to get more targeted ads to you. A few of these are malware, but actually not that much. Bootstrapping social networks turns out to be another one. This is why the past mobile social network was trying to get your contacts list, so they could also try to see if your friends wanted to join. They could also link up your social networks and so on. Another kind of thing, too, is that, well, it's also just easier to request all permissions. If you're a programmer, you don't know what your future uses are, just say, I need everything. And then later on, people accept it, and then you can also start using them later on because people have already authorized it. If you also look at the state of the art, it's also not very useful in terms of protecting people. So this is sort of an older version of what the Android permissions list looked like. But basically, it's saying, before you install this app, it's going to use your location, course, and course network base plus find GPS location. It's going to read your service configuration. It requires full internet access. It requires access to all your accounts and also system tools too. And there actually have been studies showing that people don't understand this and people don't read this. But I think that you'll probably be able to believe me if I just say that. So here's sort of the main idea. This is a paper that's about to appear in UBCOM 2012. And sort of the two main ideas we had here is the first one's a mental models one. So we want to try to find the gap between here's what the app is actually doing, and here's what people think the app is doing. Right? So try to find what the differences are between those two things. And the second idea we have here is to use crowdsourcing to try to find these gaps. Okay? So basically, we're trying to crowdsource privacy. We're paying people a little bit of money to try to find what these differences are. And so let me give you a concrete example of the first one. This is actually a picture of my brother's Nissan Maxima when he was still driving that. And it turns out he was driving his car wrong for over a year before I pointed it out to him. Okay? And now that I mentioned this to you, many of you have probably noticed exactly what the problem is. It turns out he was driving in third gear instead of fourth gear for over a year. Right? And you can sort of see why he might have been able to do that, because it turns out that he didn't realize that 3 and drive are actually different things. It's left and right. But you also notice here, that's the only place where left and right actually matters. And if you have an older Maxima, it turns out that you can't have this problem at all. Everything's on a single line. Right? So this example actually shows lots of different concepts in human-computer interaction. But the main one I want to show you is that there's a gap between the way my brother thought the car worked and the way it actually worked in practice. He just never noticed. He just never noticed it. And so he thought they were the same thing and was driving for over a year on this. And I want to make clear, my brother's a really smart guy. I mean, he's got... Yeah. Right. Yeah. Anyways, my brother, as I mentioned, he is a smart person. He's got one of the Tesla Roadsters now, so he doesn't have this problem anymore, which, by the way, is really fun to drive, too. So this is HCI, one of the main concepts of HCI in a nutshell. So you have 3 different models for any system that exists. There's how you, as a designer, intend people to think about the system. There's how people think about the system. And then there's the actual implementation of the system. And so you create the system, and people interact with it, and that's how they sort of get a mental model of how they think it works. And in an ideal world, the design model and the user model should be sort of well aligned too. So if you intend people to think in a certain way, hopefully people will also think in that way. And this is where we come into the privacy part. So let's apply the same idea of mental models to privacy. So we compare the app to what people expect an app to do, and then we look at what it actually does in practice, and we compare what the biggest gaps are between the two. Okay? So an example is Angry Birds. So I don't know if many of you have played Angry Birds before, but it turns out it actually uses your location data. And I'm betting most of you actually did not know that. So that's an example of a gap in the knowledge. So many of you think that it does not use location data, but it actually does in practice. And if lots of people have this gap, then that's something we want to emphasize. The second part is, how do we actually find these gaps? So our idea here is to use crowdsourcing. And so if you look in practice, very few people actually read privacy policies. In fact, the only time I am aware of when people read privacy policies is when I assign it as a homework assignment. Right? So, and if you think about it, there's a lot of reasons. We want to install the app. We want to play this game, or we want to try to use this app. We're not here to read the privacy policy. Reading privacy policies is not part of your main task. Again, you want to use the app, not read the privacy policy. There's a lot of complexity. It's really painful to read a lot of these kinds of privacy policies because you don't understand what's going on. And there's also a clear cost, which is your time, for a very unclear benefit. You don't know what kind of benefit you're going to get out of it. And so the idea here with crowdsourcing is we can actually address all four of these. So if we are paying people to read these things, then they're actually not installing an app. We're just paying them to read it. So there's no app to install. Reading these policies is not part of the main task originally, but since we're paying them now and we're making the main task, it is now the main task. We can reduce the complexity by having them only read parts of the privacy policy at a time rather than the whole thing. And there's a clearer benefit, which is we're paying people to read these things now. And so to sort of jump to the punchline here, this is sort of the interfaces that we came up with. So it's very similar to what the current versions of the Android permissions look like, but the main thing we're showing you here is surprises. So this is actually from real data that we captured from crowdsourcing. 95% of people were surprised that the flashlight app was sending their approximate location to mobile ad providers. Same thing with unique phone ID as well, too. So this is sort of the result of one of the conditions we had. This other one also has the same thing, but also shows you the reason, based on our analysis, as to why it's doing it. So 25% of users were surprised this app sent their approximate location to dictionary.com for searching nearby words. It turns out the dictionary app that you can download for Android phones, it does use your location data, but not for ads. It's actually letting you search for what are other words people are searching for near me. Right? It's a really bizarre feature, but it's not obvious that that's what it's doing. Right? And if you sort of take a step back and look at privacy in general, turns out expectations in privacy is a really common issue in terms of discussions of privacy. So Katz versus the United States, this is a really famous kind of court case where people are looking at, what are the expectations of privacy for wiretapping? Can you actually listen in to someone who's in a phone booth or not? And turns out, well, it depends on their expectations of privacy. If the phone booth door is open, then they probably wouldn't have expectations of it, but if it's closed, then they probably would. And so it was sort of funny. It all hinged on some really basic concepts of how people thought about privacy. A whole bunch of other philosophical papers looking at privacy also have the same thing. How do these kinds of issues and expectations affect people's perceptions of privacy? How those expectations are governed by norms, past experiences, your current situation, and so on. So our main contribution here is just trying to figure out how do you operationalize this sort of philosophical notion of expectations and how to use it in design. Yes?
Just wondering what you think about why do you think that expectations for apps versus in the past desktop tooling and laptop by default apps everything
Well, I'm not sure if I would agree with the basic premise that people expect more privacy from the apps than the desktop. I think the main thing is that the main reason we're looking at apps is because it's more of a problem that I think we have leverage in the research community. Whereas for desktop apps, there is no centralized market. It's harder to have leverage there and so on. It's much harder to understand what the resources a desktop app is using because there's nothing like the manifest that says it's only going to use location and these other kinds of things. So if we had something like that for desktop apps, then I think we could do the exact same kind of research. But without that, I think it's much, much harder to get leverage out of it. So in the long term, I think something like that would be really great to do, but I don't know what the best angle of attack to make it tractable at this point. So what we did in our study is we showed crowd workers screenshots and descriptions of our app. This is straight from the marketplace. We showed them the exact screenshots as well as the exact same description. We showed them permissions one at a time, and only the ones that are related to privacy. And we had two different conditions. The first one is we asked people, why do you think this app is using this permission, and how comfortable they were with it. And in the purpose condition, we gave an explanation based on our best analysis of what the app was doing, as well as asked them how comfortable they were with it. So the main difference is, again, is we just tell them, this is what we think the app is using it for, and this one is they have to take their best guess. We recruited people from mTurk, US people only, for our Bozo filter to get rid of people who were probably just, just there for getting a quick buck. We asked them, what version of Android OS they were using between subjects, so people were only in one condition, not in both. Turns out of the top 100 apps, only 56 of them are used on the Android marketplace. Only 56 of them are requesting use of, some kind of privacy-sensitive information, so unique phone ID, contact list, or location. So if you look at this, this leads up to 134 app and resource pairs. So for example, Angry Birds asks for unique phone ID and also asks for location, so that would be 2 of these. And then 20 participants per pair per condition, so basically 5,000 or so tasks. Here's sort of a quick summary of some of the results. This is some of the apps in the expectations condition just for location data. And basically what this means is higher means people were more comfortable with it, and lower means they were less comfortable with it. So basically if you ask people, are you okay with Google Maps using a location, almost everybody says yes, because they can sort of understand why it's using it. For Gas Buddy, that's basically showing you the nearest cheap gas. Almost everybody was okay with that. But if you sort of jump down, you'll see that there's some where people are a little bit unsure of. So here it's like Evernote. How does it actually use location? It turns out if you haven't used Evernote, it's basically tagging the notes that you're creating so it knows where you created it. So it'll be able to say, you created this note in Pittsburgh. And then Flashlight and Toss It. Toss It's a game where you're throwing a crumpled up piece of paper in a trash can. So it turns out people were very surprised at this. They just didn't understand why it was using location data. Yes. Go ahead. Most likely advertising. That'd be my best guess. But maybe. Okay. Yeah. But if you want to be really conspiratorial about it, you could probably say, well, they're in coordination with the NSA and the RAND Corporation to try to track where all the people in the U.S. are. That would probably be the more fun explanation. But JN has probably the correct explanation. Yeah, Jay? Yeah, that was a little bit surprising. We don't have the qualitative information as to why people had that perception. It might also be sort of a mental model thing that people don't quite understand how Foursquare works as well. To the best of our knowledge, it doesn't. This is just location data too. I don't have it offhand. I don't have the variance offhand. But one thing we did see is that there didn't seem to be a statistically significant difference between people who used the app before and people who haven't, which is also sort of a good finding because that means that you have a larger pool of people that you can work with to try to understand this. Here's the most unexpected thing. So basically, it was contact lists. So Pandora, Go Launcher, and Backgrounds trying to request your contacts list. We did find a strong correlation between expectations and comfort level. I think this isn't too surprising. But basically, if you ask people, did you expect this, and how comfortable are you with it, it turns out to be almost the same kind of question. Also, we found out if you show a purpose, and of course, I know what you're going to say next, which is it actually the purpose or any purpose? But if you just show a purpose, it actually does lower people's concerns across all the different kinds of permissions. So you can see over here, the comfort level, 0.4, 0.66, and so on. So again, higher is better here. And so if you have comfort without the purpose, you'll notice that all of them are much lower, and statistically significantly so in all cases. So the biggest increases turns out to be for the dictionary. Again, this is the location. It's trying to find nearby words. Shazam, so that's the one where it tries to, if you hum the music tune, it'll try to figure out what song it is. Air control light, and other kinds of things too. So again, even if you just say, okay, we are getting your location, and we're using it for advertising, that's still better than just saying we're getting a location, where people have to guess what's going on. And then here's sort of the main ideas for the new summaries. Basically, we try to simplify the terms and bold the main permissions to try to make it easier to read. We focused only on permissions that affect privacy, so we got rid of things that didn't really affect privacy. And we also try to sort by the highest number of surprises. So the highest one, 95% in this case, as well as adding the little icon if it's above a certain threshold. To evaluate the summary, we also try to ask people, see how effective they were in practice. We chose 5 different mobile apps. We had these 5 apps over here that, based on our previous study, we used the real data that was there. We showed them the same description, screenshots, and summary. We asked people about the app behavior to try to understand, are they useful in terms of conveying the behavior? Would they recommend the app to their friends? And we try to ask other kinds of basic questions as well, too. And sort of the main kinds of things to take away from this one is that the new privacy summary was consistently more accurate, statistically significantly so, where people could answer questions more correctly about what the app was doing. It turns out it was faster in 2 of 5 cases, but the problem is that people were still spending 40 to 60 seconds reading it, so that's still too high from what our sort of goals are. And so we will still want to see if we can evaluate new kinds of permissions. So to see, can people understand this in just a matter of seconds? And we also are trying to build better kinds of tools to help automate this crowdsourced analysis. So this is sort of like one of the crowdsourcing tools we've been looking at. We're also trying to build other ones to help people dig down more into what's going on inside these apps. So the ongoing work on this one, we're trying to scale this up for millions of apps. So one of the key challenges you saw, it took 5,000 Mechanical Turk tasks to try to just analyze maybe about 56 apps. That's not going to scale really well where we have millions of apps. So we're looking at static analysis as well as clustering. So an example of static analysis might be, well, it's a game because it's in the game category, and it also uses the location data. And it might also use this third-party toolkit. So when we try to slice this up into different ways and try to understand, are there commonalities inside of people's perceptions about these? And then based off of this, can start building models that might predict people's perceptions of what the privacy will be based off of a small set of data. Right. Well, that's sort of the idea behind the clustering idea. So if you look at iPhone or Android, they already categorize what it is. Like it's a game or it's a office productivity. It also has a whole bunch of metadata too, like here's how much it costs, here's what the ratings are, here's who manufactured it, and so on. So based off of all that metadata, plus some basics about the actual binary of it, so based on some really simple dissection, can we start applying clustering techniques on that to try to understand, it seems to belong in this category, it seems to belong in this category, and this category generally has low privacy concerns, or this category tends to have high privacy concerns. So that's sort of the general technique that we're aiming for right now. Yeah. So I mean, that's another kind of idea that we could look at, or even the reviews as well too. So that's something that we currently haven't really been looking at. Mm-hmm. Well, this goes to, I would say this goes back to this very last one here. How can we make these things more glanceable where you can convey the higher order bits in just a matter of seconds? And I'm hoping that if we can make a breakthrough in that area where it's useful and effective in just a matter of seconds, then if people want to drill down and try to find more, then I think that might be an effective way. But I understand your basic question. I mean, it's a really tough one that I think is beyond the current state of the art. I think we just don't know the answer yet. Yeah, well, probably not because people get inured to it. But sort of another strategy that we're looking at that I haven't mentioned here is that sort of shaming developers as well as making it easier for them to understand here's why it gave you a bad privacy score so that they can start trying to fix some of those things too. Right? And so, part of our target audience, if you look at any of these smartphone ecosystems, you can target the OS, you can target the developers, the marketplace, or the end users. Basically one of those 4 kind of stakeholders. And we're trying to look at how we can sort of impact all those different ones right now in different kinds of ways. So the developers one, I think, is also an interesting angle that people haven't really looked at. How do you help them make better kinds of apps that are more respectable of these? Was there another question here? Yeah, second. Yeah, I think that's a really good question. One thing I think would be useful to do is maybe we can also apply crowdsourcing at an overall level. Like, would you be willing to recommend this to a friend? Which is part of the reason why we're asking that question. So given that you see all these permissions, do you think this is a good idea to install this or not? And I think that's sort of like the high order thing. Should a person like me really install this? And if we can sort of summarize and distill that, I think that would probably be the most useful one. There might be other kinds of things too, like Well, I'm not sure. We probably have to think about that some more. We'll wait till you're back at CMU. We can talk about that some more. Yeah, so anyways, yeah. How do we scale this up? Are there better ways of actually labeling the behavior of apps? So again, this is based off of our best kind of estimate on what the behaviors were, based off of some static analysis, some dynamic analysis. And doing this at scale. And lastly, how do we make these things more glanceable and understandable in just a matter of seconds? All right, so that's pretty much it. That was a whirlwind tour over what we've been doing over the past 2 years or so. So lots of acknowledgments for all the people who have been funding this research. And if you're interested in seeing more, just feel free to contact me. I'm available for lunch and other kinds of things. I'm around here till 5 o'clock today. So. All right, thank you, everyone.